Thank you. Good morning, everyone. Thank you, Mr. Chairman, for your gracious introduction, and thanks to the 30th World Buiatrics Congress for your invitation and warm hospitality. My name is Cheng Jia, and I am a PhD student supervised by Professor Dr. Bo Han in China Agricultural University, and this is the second year of my PhD study. So it's my great honor to have this opportunity to give a presentation in this special place. Okay, my research title is Antimicrobial Resistance Profiles of 5 Common Bovine Mastitis Pathogens in Large Chinese Dairy Herds. And my presentation covers these 5 parts. In the first part, I will introduce my background of my research. And in the second part, we'll show the simple MSC method. And in the third part, all of the data were shown in the results. And finally, the conclusion and acknowledgements. What is bovine mastitis? When the normal bovine mammary gland becomes inflamed, accompanied with swelling, pain, warm, redness, and bovine mastitis happened. So, bovine mastitis is the inflammation of one or more quarters of cows. Inflammation of bovine mastitis. Inflammation of bovine mammary gland affects milk production and milk quality. And decreased milk production is often due to the direct effect of pathogen or damage caused by the host immune response. Also, additional cost for therapy, discarded milk, reduced milk production, culling, and replacement can cause significant economic losses to the dairy industry in the world. And in China, it might cost $200 to $600 for one cow every year. And bovine mastitis can cause, and there are a lot of pathogens can cause bovine mastitis, according to which included bacteria, fungi, mycoplasma, and various. According to our previous publication in our laboratory, Dr. Gob reported that the 5 common bovine mastitis pathogens are E. coli, klebsiella species, CNS, Streptococcus species, and Staphylococcus aureus. Bovine mastitis is the most caused disease to the dairy industry, and antimicrobial therapy is an important tool for controlling mastitis. Over time, antimicrobial resistance developed, and the ability of microorganisms to stop an antimicrobial becomes stronger. So, subsequently, AMR is one of the biggest threats to global health, food security, and development today. Knowledge of the trends of antimicrobial resistance is very important to identify the antibiotics efficacy and help guide the veterinarian to select the most appropriate antibiotics to control the bovine mastitis. Therefore, the objective of this study to determine the AMR profile of this bacteria isolated from clinical mastitis in large Chinese dairy herds. So this is the 11 antibiotics used for Staphylococcus aureus as Streptococcus species, and 8 antibiotics used for klebsiella species and E. coli, which included 2 antibiotics highly critical for human and others commonly used in veterinary. And in our research, phenotypic AMR was obtained using MSC microdilution method followed by the CLSI guidelines. And this is all of the breakpoints we used in this study. And according to the CLSI or UCAS documents, most of the antibiotics have the available breakpoints, and but only a few antibiotics have the veterinary-specific breakpoints. For other antibiotics, breakpoints based on the human interpretive criteria. And let's show the results. in our research, totally 541 bacteria isolated from clinical mastitis in 45 large Chinese dairy herds from these 10 provinces. And this map is the distribution of the 10 provinces in China. And we have 103 Staphylococcus aureus from 26, 107 NS from 23, 101 Streptococcus species from 41, 100 E. coli from 28, and 130 klebsiella species from 45 dairy herds. Now let's show the MSC distribution of these 5 isolates. First, for the Staphylococcus aureus. Among these 11 antibiotics, resistance to penicillin, 60% were the most common, followed by the clindamycin, about 20%. For the MSC negative value, the highest is also penicillin, more than 64 microgram per milliliter, and followed by the clindamycin and the tetracycline. And this is MSC distribution of NS, and the resistance rate is more severe than Staphylococcus aureus. Also, among these 11 antibiotics, resistance to oxacillin and penicillin, more than 60%, were the most common, followed by the clindamycin and tetracycline. For the MSC negative value, the highest is clindamycin and daptomycin, more than 64, followed by the enrofloxacin, penicillin, tetracycline, and vancomycin. And this is the MSC distribution for Streptococcus species, and resistance to tetracycline, about 60%, were the most common, and followed by the clindamycin, about 30%. For the MSC negative value, the highest is clindamycin, more than 64, and followed by the tetracycline. And this is MSC distribution for klebsiella species. And among these 8 antibiotics resistant to amoxicillin and tetracycline, more than 30% were the most common, and followed by the polymyxin B. For the MSC negative value, the highest is amoxicillin, safety offer, followed by clindamycin and tetracycline. And this is the MSC distribution for E. coli. Also, among the 8 antibiotics, resistance to amoxicillin is the most common, and followed by the safety offer and the polymyxin B. For the MSC negative value, the highest are amoxicillin and polymyxin B, followed by the safety offer, clindamycin, and tetracycline. Okay, let's take a quick look about those 5 tables. The red one shows the high resistance rate, while the blue one shows the lowest resistance rate. For Staphylococcus aureus, the highest is penicillin and the lowest is enrofloxacin. And for NS, the highest is oxacillin, while the lowest is safety offer. And for the Streptococcus species, the highest is tetracycline, and while the lowest is enrofloxacin. And for klebsiella species and E. coli, the highest is amoxicillin, and the lowest is enrofloxacin. Okay, for these 4 for these 4 antibiotics, high critic for human medicine, resistance to these 5 isolates ranged from 0 to 24%. Okay, according to the previous publication compared to Europe, except for the tetracycline to E. coli, the higher resistance rate was shown in China, which included penicillin, amoxicillin, cephalexin, safety offer, tetracycline for Staphylococcus aureus and Streptococcus species, and amoxicillin and safety offer for E. coli. And in conclusion, in these large Chinese dairy herds, Staphylococcus aureus and Streptococcus species isolates were highly resistant to penicillin and tetracycline, whereas NAS were more often resistant to amoxicillin and penicillin. Also, both E. coli and klebsiella were frequently resistant to amoxicillin, carbonate potassium. Resistance for 4 kinds of antimicrobials highly critical for human medicine ranged from 0 to 24%, which indicates that mastitis pathogens could be a potential threat to human health. Finally, we would like to thanks to all of the authors for your contribution to our research. And this research was financially supported by the National Natural Science Foundation of China and the National Key Project. Thank you for your attention.